so I'll catch the second wave in about 15 minutes. There is one student on the call right now, Mr. Got Game. I'm not sure who you are. So that's the only person that didn't get attendance. You just have to. So if you're trying to update your name, I think you have to do it before you get on the call. Let me get these students. Like, I think if you try to do it while you're on the call, it might not let you do it. So you can either log out and then log back in. Let's see. Or put it in the chat or something. But again, there's one student on the call right now. I don't know who you are. So if you want attendance credit, you just have to identify yourself. Okay, let me share my screen. Also, there's another student that just joined. Be sure that your last name is showing so that, I can make sure that you get your attendance credit. Okay. Let's go here. Yeah, you don't, let me see. It means I have you. It's only two. There's one student, Mr. Caleb, but I think I found you. But again, to minimize ambiguity, just show your student name. And then there's another student, Mr. Got Game. I don't know who that is because I don't even see a Jordan. I don't even see a Jordan on my roster. So, but everybody else, yeah, I see it now. Yeah. So just everybody else I was able to get attendance credit aside from those two, Mr. Got Game. Well, actually, it's just the one. Mr. High, I got you. Just get down. Stop. Get down. Single page. Okay. Oh, it's doing this thing. That's a little bit annoying. How do I get rid of this? Okay. Nope. Where'd it go? There it is. Okay. That probably does need to charge. Give me just a moment. This on the charger. It's so many moving parts to the setup. I think we're ready to go. Okay, so we are at the top of week 5. So I think your midterm exam was due last night, right? Either last night or right now at the start of class. It's one of the two. But it was due. It should be due by now. So is it midterm? Sorry, that's not midterm. That's your exam 1. I think also this class. So there's 2 main components. We have our assignments in my math lab, and then I think this class also has a lab component. So just make sure that you're doing that. Let me see, who's that student? Because if they don't, okay, let me see. Maybe that's who it was. Okay, I see it now. Yeah. So as a courtesy, I was just saying something. As a general rule of thumb, you definitely want to show your first and last name. Okay. But yeah, I've updated. So I think everybody on the call has their credit for the day. Yeah, just we're making our way through the assignments. So, we had the holiday last week, so we didn't meet last Monday. Okay, let me say, I just got an email and I'm going to share it with you all. It says starting Monday, today, mathematics tutoring will be available in Dansby Hall 304. Monday and Wednesdays from 3 to 5. There will be at least 3 tutors, and the courses to be tutored include College Algebra 1, College Algebra 2, Finite Mathematics, Trigonometry, Basic Stats, Calculus 1, Calculus for Business, and Calculus 1 and Cal 2. Some students may be willing to tutor upper level mathematics. If any questions regarding the classes, please contact me. Somebody by the name of Alicia Austin. Okay. So yeah, so I read it, but so yeah, that's why I read that, because I think that's apt, that's relevant to our experience, right? So by now, hopefully you all are catching the swing of things. I feel like the rhythm is not too intense. I mean, we're really just working on like one section a week. So we just finished exam one, covering sections 1.1, 1.2, and 1.3. So that means today we're going to be working on section 1.4. Oh, let's go back. Okay. I don't know how to, let me see. There's a setting I can change. No. Yeah, I don't know. They've recently, that's it. Because it was working fine before, but I guess some update that they've done, it just kind of sent things sideways. But anyway, we'll work with it. I think we can work with it. So, okay. So we continue. And again, as usual, if you have questions about anything or if anything is not clear, feel free to either unmute yourself or type in the chat. I'm assuming my audio is working. Yeah, testing. It looks okay. Let me check this one more time. How many labs do we have to do? So questions about the labs, I had to redirect you to Dr. Lamar. She usually has her own, like, it's not like the number of labs. You're trying to get to a certain level of proficiency. So you had to answer that question. Let me see if I got some people. Look at these gentlemen. One, the other one was Dansby. Yeah. So the tutoring is in Dansby 304. I think it's Monday and Wednesdays from 3 to 5. Okay, that's a good question. Let me let these gentlemen in. So you see how, like, if you join late, you miss like vital information for your everyday life. I don't know if you guys know, what's that show? Oh, that Gloria Bettenberg. That's like, man, I think I was a kid in the 90s. So, that's a throwback. I do not expect you all to know that reference. Anywho, okay. If you're just joining us, I think the most important thing, so as we were kind of getting set up today, I got an email saying, it was about tutoring. I think it's Monday and Wednesdays from 3 to 5, and right? So you can either just go there at that time or maybe contact the math office and see if they are open to like remote tutoring as well. Also, you guys can use my office hours, but I mean, the way I explain it, I mean, you already kind of know how I'm going to explain it. Like the way I kind of either do, like when we did the study session last week and the way I do the examples, that's kind of the same way that I explain it. So, if you're not comfortable with me, hopefully you all either have like a classmate that's getting it, or you can use like the tutoring service that we just discussed. Let me check one other thing. Oh yeah, that definitely needs a charge. Okay, so let's see. Let's get the focus. Let me see something. No, how do I get that? If I go like this, I think that does it. All right, well, we'll work with that. Okay, so I still don't really like the way it looks, but they keep changing. It's kind of annoying. Sorry. Yeah, the app just kind of keeps changing my formatting, and I don't know. I don't really know how to get around it right now, but that's okay. Let me see something here. Ooh. Interesting. Okay. All right, let's just go with this. All right. So again, we just completed exam one over sections 1.1 to 1.3. Honestly, okay. So now going forward, right? If you're trying to improve your grade, like honestly, this is like a free. This is like an Easter egg or a hidden gem. Honestly, anybody that wants an A can get it. And all it takes is, again, because our assignments have unlimited attempts and only a 10% late penalty. If you make less than a 90 on any assignment, I would go back and do it until I get a 90. If you're just trying to accumulate, like maximize your overall grade as quickly as possible, prioritize your exams. Your exams are going to have a heavier weight. Like the homework is really there for you to practice to get you ready for like the exams. The quiz kind of emulates the exam, and then you should have seen by now, you know, you can't see your score in the exam until you submit it, but it should be unlimited attempts. But then you should have also noticed that each time you take the exam, it completely changes it. This should be a completely different exam. It's the same content, but it's just going to be a different exam, right? So then it becomes a game of, you know, endurance and know-how, like in savvy, right? Like if you're confident in the material, then you know you can probably get a higher score in fewer attempts, right? But it doesn't hurt you. It's like, again, if the system is going to take your highest score, so you know, if I know if I were a student and I made below a 90 and I get unlimited attempts, I would at least try to get to like a high 80 or something. But that's, again, it's whatever you want. I'm really here just as a facilitator. Man, this is really weird. So it's 9/11. Give me just a moment. Oh, I missed it. That's okay. But today is September 9/11.
Morehouse?
Yes. Anywho. So, you know, I just kind of wanted to take a brief moment just to like remember people, you know, the lives that were lost in the 9/11 tragedy from 2001. Okay. So that was a moment. Okay. But yeah, so yeah, I can't think of anything else there. I'll check attendance again in like just about 2 minutes for anybody that's coming late. And let's keep moving forward. So here we're going to be looking at section 1.4, a library of functions. And so what we're going to be doing with this section, we're going to start to explore like some of the graphing techniques. The main graphing technique that we've already explored is basically plotting points. We choose, like so far what we've done is we choose several values of x, pass those x values through the function, and then find the corresponding y values. It generates a set of ordered pairs, and then we plot the points and connect them either with a straight edge or a smooth curve, right? So now we're going to start looking at the next progression on graphing functions. And so we start this journey of graphing with starting with a library of basic functions. A few objectives here. One, we'd like to define what do we mean by linear functions. 2, discuss important properties of functions. 3, graph square root and cube root functions. 4, evaluate and graph piecewise functions. 5, graph basic functions. 6, find the average rate of change of a function, right? So these are our objectives here. Okay. So let's start with linear functions, right? That's the first type of function that we discuss in our library of functions. So let m and b be real numbers. Then the function f of x equals m of x plus b is called a linear function. So I think we kind of discussed this where we had lines. You may have seen this as y equals mx plus b. So now when we start to discuss functions, we can use y interchangeably with the notation f of x, right? So if m is 0, the function f of x equals b is called the constant function. So if you have your f of x equals some number, that's just going to be a horizontal line through y equals whatever that number is. If m is 1 and b is 0, the resulting function is called the identity function. Right, so whenever we have y equals x, that's just going to be a diagonal line passing through the origin with a slope of 1. Okay, so these actually are our first 2 basic functions. We have a constant function, which is just a flat horizontal line through whatever y equals that number. And then we have the identity function, y equals x. That's going to be a diagonal line with slope of 1 passing through the origin. Okay. So the graph of a linear function is a non-vertical line with a slope m and a y-intercept b. Notice in the graph on the left, as we trace it left to right, the image rises, it goes up. So we say that one has a positive slope, right? So at the bottom it says m is strictly greater than 0, that has a positive slope. In the second image on the right, our m is less than 0, that has a negative slope. Notice as we trace it left to right, the image falls. As we trace it left to right, the image falls. Okay, let me check on Zoom real quick. I think you guys look good. Okay, I think the chat is okay as well. Okay. Okay, let's keep moving. Let's see. So in this example, we're asked to write a linear function g for which g of 1 is 4 and g of -3 is -2. Okay. And oh, good job. So we're asked to write a linear function that I'll fit this data to a linear function. So that's going to be our y equals mx plus b. I'm going to label it as f of x equals mx plus b. Okay. So let me see. So for instance, we're given that when x is 1, the corresponding y is 4. When x is -3, the corresponding y is -2. So these are the two order pairs that we were given. So whenever I'm given like order pairs like this, I like to just automatically label them like x1, y1, x2, y2. Okay. All right. So give me just a moment. Okay. Any suggestions as far as the next move? Like, what do you guys think? What would you do if you see something like this? You have two order pairs, and we're trying to find the equation of the line through these 2 points. What do you think? Right? Maybe find the what? Find the slope, right? So I don't know if you remember before when we mentioned lines, but I was like, okay, there are 3 formulas you typically want to have ready to go whenever we're working with lines: the slope formula, the point slope formula, and the slope intercept formula. Generally speaking, I don't use the point slope. I'm either using the slope formula or the slope intercept. Slope intercept is y equals mx plus b. So let's start by finding the slope between these guys. Okay. So the slope, that's going to be our rise over our run, which is our change in y over change in x. So that's going to be y2 minus y1 over x2 minus x1. Okay. If we plug in the corresponding components, okay, our y2, notice that I started with a blank set of parentheses. All right. The blank set of parentheses helps us to keep track of the signs of the negatives, right? Without the parentheses is easy to like mix up your signs and make a mistake, right? So our y2 is -2, our y1 is 4, our x2 is -3, and our x1 is 1. So then on top, it looks like we have what? -6. On bottom, we have -4. Double negative becomes positive. This reduces down to 3/2. Okay, so that's our slope. So now we could use a point slope, right? We have at least one point. We have the slope. We could use the point slope, but I think I'm going to use the slope intercept. Slope intercept formula, right? So that's like you can say that's your y equals mx plus b, or you can say f of x. I'm going to do y equals mx plus b. Okay. And I'm going to plug in the first point because it looks easier to work with because it doesn't have the negatives. So I'm going to use that point. So let me see, my slope is 3/2. If I'm using that first point, my x is a 1. We don't know our y-intercept, and then our y is 4. Notice here we have one equation, one unknown we can solve. Long story short, b is going to be equal to 4 minus 3/2. What is that, 2.5? So 5/4. 5/2, right? Okay, so that's our y-intercept. That's where it crosses the y-axis. So then if we want the function, if we plug in the slope along with the y-intercept, let me move this over. I'll just move it here and I'll work here. So then long story short, we're going to get what? F of x equals our slope, which is 3/2, x plus 5/2. So this should be the equation of the line passing through those 2 points. Now we can actually verify this. You know, we don't, we're not really done at this point. We can actually check and make sure that this makes sense in the context, right? So for instance, when x is 1, the corresponding y should be 4. 3 halves plus 5 halves is 8 halves, which is 4, right? So this point checks out. Okay. Okay. And then for the next one, when x is -3, the corresponding y should be -2. So that's going to be a -9 halves plus 5 halves is a -4 halves, which becomes -2. So both of these original points check out in the function that we found, so we can be confident in this result. Okay. And then we have a type version here. So first they found the slope, right? So first they identified the ordered pairs that were given when x was 1, corresponding y was 4. When x was 2, when x was -3, the corresponding y was -2. So then they got the same slope that we got. And now see, here's an example where they use the point slope, right? They use the point slope. Point slope is y minus y1 equals m times x minus x1. They plugged in their slope. They used the first point because it was easier with the signs. So this and the slope. And then through algebra, they get the same thing that we got. I'm so grateful that these sessions are only 50 minutes, man. I'm like struggling over here. And like I felt it coming. Like I woke up early to just kind of get my notes together and kind of organize and kind of be ready. And then it was maybe like 15 minutes on the clock, and I was like, before class starts, and I just got really sleepy. I was like, no. So I just turned everything off, put on something I could like listen to. I think I've been watching like The Flash on Max. The one that came out in theaters is already on HBO. So I just put that on because I can listen to that and like I know what's going on. So it encourages me to close my eyes. So then I close my eyes for like 10 minutes before class. A lot of times I'll be running late, either like I'm groggy, like because my alarm is either, just something with the alarm, or I might be being irresponsible. But these classes are short and sweet, so I really do appreciate that, especially because they're remote. So then I can do what I need to do. All right, so let's look at this. So what do we mean by increasing, decreasing, and constant? Let me see something. It would be nice if I can see that. That's okay. This is a long section. Okay, so we'll do the best we can with this section together. Again, the recording for this should already be available. Depending on where we stop today, on Wednesday, we can either
Morehouse
pick up in the notes where we left off, or if you guys want, we can work on the homework together, right? So we'll see how Wednesdays go. Let's just kind of keep going here. So then let f be a function, and let x1 and x2 be any two numbers in an open interval AB contained in the domain of f.
Morehouse
Connection. Okay, I'll mark him as excuse. He got lucky I saw his, because I was like, yeah, he's usually here. I mean, if he gets into the waiting room, I'll let him in and give him credit. Let's keep going. So increasing, decreasing, and constant functions. So given those conditions, the symbols A and B may represent real numbers, negative infinity or positive infinity. Then we have the following is going to be the case. So one, we say that f is an increasing function on an open interval AB if whenever x1 is strictly less than x2, that implies that f of x1 is strictly less than x2, right? So that's like a formal definition. Basically, what do we mean by an increasing function? We generally ask increasing, decreasing, and constant by looking at the graph. And so, long story short, as you trace the graph from left to right, if it goes up, then we say the graph is increasing, right? So notice as we trace this graph from the left to the right, it's steadily rising. So again, what was given was a formal definition, but essentially what they mean is as you trace it left to right, it goes up, right? So if that's an increasing function, then a decreasing function should be the same thing. And the only change from this formal definition would be the last line where it says it should be f of x1 should be greater than f of x2. And pictorially for decreasing, that should be, when we trace it left to right, it should go down. All right, so here's an example where f is a decreasing function on an open interval AB. Whenever x1 is less than x2, that implies that f of x1, the corresponding y's, are decreasing, right? F of x1 is strictly greater than f of x2. Notice as we trace it left to right, our graph goes down. It's going down, all right? So again, the way we normally see it, we're looking at an image and we describe increasing, decreasing, and constant based on our intervals on the x-axis, all right? Based on open intervals, okay? Okay. And the reason we do open intervals is because that always forces us to have at least 2 points. If these were like closed intervals where these are square brackets, then if we were on the point A, we wouldn't have a point to the left to compare it to, right? But when it's an open interval, you're always going to have 2 points to work with within the interval, right? Because we're not going to be on A, so we'll always have 2 points to work with. Okay, but that's neither here nor there. And then so a constant function is where whenever x1 is strictly less than x2, our y values are basically equal. They're always equal. So then pictorially what that means is as we trace the graph left to right, it neither goes up nor it goes down. It just stays flat or constant. Okay. So hopefully we're all aboard and we're not all aboard and this makes sense. Again, if anything is not clear, feel free to unmute yourself to get my attention and we can talk about it, or feel free to type it in the chat. And so with that, let me actually check on the chat and things. Okay, I think I got some people here. Okay, let me update my attendance. So that's going to be here. And I see him. Who else? This one and this one. So yeah, I mean, you guys are so far, you guys have been pretty good, like getting your assignments in, being diligent about communicating and getting your attendance. So I've been kind of chill with the attendance. I haven't as long as you make it into the Zoom at a reasonable time now, I mean, and it's not like, if I know that it becomes like habitual or a lot of like tardies and stuff like that, then I might start to change that. But for the most part, you guys have been chill. So if you're chill, I'm chill. I'm going to match you guys, right? So yeah, if you're just joining us, I went on to give you attendance credit. You definitely might want to, once the session is over, go back and check the recording to hear the announcements, the things that we said earlier when we first started. Okay, let's keep moving. Okay, so in this example, it says, from the graph of G, find the intervals over which G is increasing, decreasing, or constant, right? So we just saw, basically, we're going to be looking at it as we trace the graph from the left to the right, right? So if we look, initially, what is the graph doing? Is the graph increasing, is it decreasing, or is it constant? All right, is it increasing, is it decreasing, or is it constant? So notice initially it's increasing, right? So as we trace it from the left to the right, it's going up. So we would say that this is increasing. I'm going to abbreviate it as an up arrow. It's increasing on the interval. The far left is what? Negative infinity and up to -2 on the x-axis. Okay, and we always do parentheses when it comes to this concept, this discussion. Okay, so then next, after it's increasing, it's constant on the interval from, what is this, -2 to 3, right? -2 to 3, it's constant. Okay, so I'm going to abbreviate that just like with a flat horizontal line. That just means that it's constant as x goes from -2 to 3. And then we say it's decreasing as x goes from 3 to infinity. Okay, and these are the results that we get. Yeah, so I don't know. I'm a little bit distracted. I had it's not really a family emergency, but it's like just a really bizarre, I don't know. I was notified this morning, like my cousin who's like the same age as me, She just woke up. She was like, I can't breathe. And then that was it. Nobody really knows. I mean, that's where my conspiracy thing starts to kick off. And I feel like it's COVID related. And, and then it's just like you get into this thing of like, life is too short. Like we're young, but it's like, again, don't get me started on the soapbox with the conspiracies, because it's really sinister what it looks like is going on. But I just say that to say like that, I feel like if you can do something and you want to do something, just go ahead and do it, because life is way too short, and like, I mean, unless you're working on something else or whatever, but it's just really weird. And it's like, it's so wild. Like her husband is like a pastor and they got like 3 children, 3 girls. So it's just like, it's really tragic. So it's like, I'm a little bit distracted by that. I don't know. And then it's like people in your life, it's like you try to make yourself available. And like, if you find yourself arguing with folks, it's like, it's not worth it, because no moment is guaranteed, for all we know. That's kind of what happened with my dad too. It was something similar. Folks is dropping left and right. Again, that's me going back to this conspiracy stuff. I mean, don't get me started on that. We'll talk about that some other time. But anyway, we're here. We press forward and let's keep moving. So the definition of a relative maximum and relative minimum. Let me see. Okay, so if A is in the domain of a function f, we say that the value f of A is a relative minimum of f if there's an interval x1 to x2 containing A such that f of A is less than or equal to all f of x for every x in the interval from x1 to x2. And then it's a similar explanation for maximum. Pictorially, what we mean is, a relative minimum is going to be the lowest value in the local area, like in a certain region, not across the whole graph, right? And then a relative max is going to be, it's like, if you're looking at the graph, it's going to be the bottom of a valley or the peak of a mountain. The bottom of a valley will be a local minimum. The peak of a mountain or a hill would be a local or relative max, right? So like, say this is the image that we were looking at. So here would be our relative maximum values, right? And then we have our relative minimums. So the bottom of the valley versus the peaks of the mountain. So we say a function f is called an even function. So this is another definition. A function f is called an even function if for each x in the domain of f, negative x is also in the domain. And then we have that f of negative x equals f of x. All right, so this is the definition of an even function. When we evaluate f of negative x, we get back to the original. The graph of an even function is symmetric with respect to the y-axis, right? So when once we identify a function as even, we know we have y-axis symmetry. So that means that whenever we get 1 point on one side of the y-axis, we automatically get another point on the other. So we can actually use symmetry, or this definition of a function being even or odd, to help us in our graphs, right? So then that brings us to, what do we mean by an odd function? A function f is an odd function if for each x in the domain of f, negative x is also in the domain. And now in this case, we have f of negative x equals negative times f of x, right? Versus the even function, that negative is not there. F of negative x equals f of x. That's even. Odd function, we just introduced this additional negative here. The graph of an odd function is symmetric with respect to the origin. Okay. Origin symmetry, like one way to kind of describe it, if you were to put your thumb at the origin, if you cut the graph in half along the x-axis, put your thumb on the origin and rotate the top image by 180 degrees, the top image is going to match the bottom image. Another way to kind of visualize origin symmetry, whenever you have the points x comma y, you also have the points negative x comma negative y. So then all points are like symmetric and equidistant centered around the origin. All right. So whenever you have an x comma y, you also have negative x comma negative y. Okay. All right. So determine whether each function is even, odd, or right? So if you can identify a function as even, odd, or neither, that'll tell you about the symmetry, and then you can use that to generate more points to get a better graph. Right? Remember, even functions are symmetric about the y-axis. Odd functions are symmetric about the origin. Okay. All right, so we want to do a test for even, odd, or neither. So for instance, for part A, we want to evaluate g of negative x. We want to evaluate g of negative x. So what we're going to do is replace each x with negative x and then simplify. If we can get back to the original or negative times the original, then we can identify it as even or odd or neither. Okay. If we cube a negative, that final result is going to be a negative. Double negative is positive. Okay, is this the original? No. Let's try factoring out a -1. So then this is going to give us x cubed minus 4x. Notice that this is negative g of x, all right? So we have g of negative x equals negative times g of x. That's the definition of a function being odd. Another like just interesting thing, I'm a big proponent of like just healthy living as much as possible. And so recently a friend of mine sent me, she encouraged me to watch this series on Netflix called Live to Be 100. It was really interesting. So I try to encourage people to watch it. They just kind of basically, this guy realized that there were these places around the world, like at least he kind of explored 5 different locations where they had the highest density of people that were over 100, the highest density of centurions. And so he went to those different locations and just kind of, did research and like ask around and kind of interview people, and just to see if he could find some kind of common thread as to like, why is it that in these locations people were living to be so long? Like one thing I just totally resonated with was how easy the life was. Like I didn't even realize this until like recently in my life, where in like France and certain places overseas, they only work like 3 months out of the year. And then the rest of the time is their own. They can do whatever. I was like, oh my God, that's so beautiful. Because we work here and then we come home and do more work. And it's like we work around the clock and we don't have enough to just actually live. And I think that's bullshit. I think it's bullshit. So I kind of like be protesting. But then when I heard that there were actual people that they only work like three months in a year, I'm like, yo, it's time to go. And then like in another culture, like in Japan or something, they never stop working, but they love their job. They're like either farmers or they got gardens. It's like they're working on things that give them life. It's called ikigai. Like one day I actually wanted to sit down with you all and walk you through that procedure of finding your ikigai. And what it is, ikigai, I think I'm saying it right, but what it is basically finding your life purpose. There's a whole like chart, you can like research it or whatever, but it's really interesting, and it would help you to like basically identify, why are you here, like what's your life purpose. It's like a series of questions, and it's really, really interesting. But in their culture, like once they find their ikigai, that's what keeps them alive. Like they just keep doing it, and there's some merit to it, because that's essentially what happened to my dad. Like he was working for the FDA, and we kept encouraging him to retire. He did not want to retire. He kind of had to stop because he got sick. But then it was like, here this person has been doing something their entire, like most of their life, 30 plus years, if not longer. And then they just stop. And then so it's like, if a body in motion stays in motion, a body at rest stays at rest. So I now understand like why he didn't really want to retire, but it's like, again, he got sick, so that was a little bit different. But again, I think it's conspiracy, but there's no way to prove it. I mean, other than just research and just try to arm myself and try to give people heads up as best I can, and then those that want to consider it can maybe arm themselves. Like I don't know if you guys ever study like what happened in Hawaii with the Maui fires. But like, and like the houses that survived and like the blue roofs, it's so bizarre, but you know, seems like the blue roofs, anything with this like sky blue color was protected. And so in my mind, I'm like, okay, I'm thinking like, okay, if this was a directed energy weapon, I automatically go to, well, how could we defend against that? Like if we were being attacked or something like that, if this is real and we were being attacked, how could we defend? And I think, I mean, I'm assuming it would be that blue color, but maybe they might make a directed energy weapon that overcomes that color. But you know, but when you look at the devastation, anyway, it's really interesting. You know, something to consider. Let's try to get through like one or two more examples. Like we got like a couple of minutes before we'll get you guys out of here. Okay, let's do a test for even, odd, or neither on this example, right? So again, to do a test to even, odd, or neither, we change x to negative x, we simplify, and then we can see if we can satisfy one of the definitions, right? So we got this f of x, and again, we're replacing x with negative x. Okay. So the negative x squared, so negative, double negative is going to be positive. So that's going to be a positive x squared. Notice that this is equal to the original, right? So we have f of negative x equals f of x. That's the definition of a function being even. Let's just copy and paste. Paste, right? And so I don't know. It just seems like it honestly seems like people are just dropping like flies left and right, to be honest. So that's part of the reason why I'm a little bit like distracted. Yeah. Which again, I mean, I got a conspiracy that addresses that as well, but you know, I'm gonna let that be. Let's look at C. So if we do a test for even, odd, or neither for C, run out of space a little bit. Again, we're replacing x with negative x. And then if we simplify, I'm going to kind of work over here. Triple negative is going to be negative. Double negative is going to be positive. Is this the original? No. And then if we try to factor out a negative, we can't get back to the original either. So then this is an example of something that's neither. It's neither even nor odd. Okay. So with that first example, if we were to look at the image, if we were to look at the graph, it should be symmetric about the origin. We got a full minute. Let me see if I can pull up this image and I can show you an example of origin symmetry. Okay, let's go here. This one. Let's reload and refresh. I got 1 minute still. Okay, let me go to my y equals. So the first one, we had what, x to the power of 3 minus 4x, right? I'm gonna go ahead and put in a second one. X squared plus 5, okay? So now the first one, let me suppress this one. The first one we said it was odd, which is origin symmetry. So I think we described it earlier. If you were to cut along the x-axis, put your thumb at the origin and rotate by 180 degrees, the top image is going to match the bottom image. It's like rotational symmetry. Also, whenever you have x comma y, you also have negative x comma negative y. Right? Okay. So if you were to pick one point, like I think we have, it looks like 3 something. When x is 3, 27 minus 14, 27, 17, 13. But it kind of goes off the chart. But when x is, so we have, so the point 3 comma 13 should be on this graph. That also means that negative 3 comma negative 13 is also on the graph, right? And then for B, since that one was even, we're anticipating y-axis symmetry. Oh, I must have forgot my squared. Yeah. Insert squared. All right, y-axis symmetry. So whenever we have x comma y, we also have negative x comma y, right? Or in other words, you can fold it along the y-axis. Okay. Are there any questions? Let me go ahead and share this. So while you all think of a question or two, I'm going to send this, make a copy of the PDF available. Let me make sure it's in the right folder. fall traditional algebra 1 notes updated daily. And you can access these from our Blackboard. Okay. Last week we did the exam, so we're here. Yeah. Okay, so when this bar finishes loading, you'll receive a copy of the writing. So then on Wednesday, what we'll do, we can either continue with this lecture, right? Keep in mind that anything that I was saying in the lecture is already in the recording, or we can actually work on some homework assignments. Like I think we just kind of, our rhythm has been off for the past few sections or whatever, so we hadn't had that opportunity. But yeah, so Wednesday, more than likely we'll go through some homework together, okay, guys? All right, so if there aren't any burning questions, we're gonna go ahead and end the session here. From one beautiful mind to another, enjoy the rest of your day, guys, and see you Wednesday, same time, same place. Take care. Peace.
I have a question. Hello?
Can you hear me?
Yeah. What would the assignment be put inside the grade book?
What happened?
When would the assignment be put inside the grade book?
At least by the midterm. I'm kind of working on that. It's just that, like,
Okay.
yeah, I'm working on it. So
It's the more stuff that I want to keep on doing for going to grade book. That's why.
okay, yeah, I mean, the main thing is that your grades in my math lab, and like if you know you made below a 90, like if you're trying to improve your overall score, keep in mind you still get a limited attempts on all assignments. Any assignment that's been due, there's only a 10% late penalty. So if you're trying to boost your grade, I would definitely prioritize your exams, right? Because that's where the bulk of your grade is going to come from. So like if you're going back, make sure your exams, like if you made below a 90, then obviously you can take it again to try to improve your score. Because the highest you can earn anything submitted late is a 90.
Okay. Thank you.
And then like the homework and quizzes are really there just for like practice to get you ready for the exams. Those have that's going to be a lot of work for a little bit of points. So if you really want improvement, you prioritize the exams. That's a good question. Any other questions before we go our separate ways, gentlemen? Going once, going twice. Okay. Again, so if there aren't any burning questions, we'll just meet back on Wednesday, same time, same place. Take care, guys. Peace. Let me check the chat real quick. Okay, so there is a question. Let me see. As far as when do we have a midterm? It's not really a midterm. It's just going to be exam 2, and that's going to be at the halfway mark, like week 8, right? So this is week 5. So week 4 we had exam 1. It's not really a midterm. It's just exam 2, and then your midterm grade is going to be based on basically exam 1 and 2, along with the corresponding homework and quizzes. Yeah. I don't. So I see somebody ask something about an email. It's best for you to ask like right now, because when I leave you guys, I'll be ripping and running. And like if need, I can like make a private room or something. I don't know if you guys are still there, but going once, going twice. Okay.